In this video, we will find derivative of y equals x squared, and y equals x cubed. The first function is a linear function whose slope is 1. The second function is a quadratic function. The third function is a cubic function. But before we find derivatives, recall that if we are given f of x, then the derivative, by the definition, is the limits at h go to 0, f of x plus h minus f of x over h. This is not the derivative at any point, but the general derivative functions. Also, we will use a couple identity. If we have a plus h squared, then we can expand this as a plus h times a plus h, and this will give us a squared plus ha, which is 2ah plus h squared. And so what it means is that if we have the expression a plus h squared, we can replace it with a squared plus 2ah plus h squared. Similarly, if we have a plus h cubed, then we can replace it with a cubed plus 3a squared h plus 3ah squared plus h cubed. With the first function, f of x equals x, then f prime of x is the limit at h go to 0 of f of x plus h minus f of x over h. But this is the linear function, so whatever we plugged in, we end up with the same thing. This is also known as the identity function. And so if the input is x plus h, the output will be similarly x plus h as well, minus f of x is x over h. This will give us the limit at h go to 0. X minus x is gone, and we have h over h, which is 1. The limit of 1 at h go to 0 is 1. This shows that the derivative of x is 1. It is not surprising here because the slope of this line is 1, and we know that the derivative is the slope of the tangent line. Since it is a line already, its tangent line is the same as this line, whose slope is 1. For f of x equals x squared, the derivative f prime of x is the limit at h go to 0 of f of x plus h minus f of x over h, where f of x is given x squared. And so if we see an f of x in this formula, we can replace it with x squared. And f of x plus h, the input of this function is now x plus h, so instead of x, we replace it with x plus h, and then it is the square function. And using the identity or the shortcut that we just mentioned, this is x squared plus 2xh plus h squared. We now plug these into this expression, the limits at h go to 0. We replace f of x plus h with x squared plus 2xh plus h squared. And then we still need to subtract f of x, which is x squared. The denominator is still h. We can cancel out the x squared minus x squared. And so in the numerator, we are left with 2xh plus h squared. The denominator is h. We always factor out h in the numerator only. H times the quantity 2x plus h over h, and this is the reason why the h canceled out. We end up with the limit as h go to 0 of 2x plus h. But if h go to 0, then the term disappear because it goes to 0. And so we are left with 2x. This shows that the derivative of x squared is 2x. For f of x equals x cubed, The derivative function is that prime of x equals the limit at h equal to 0 of f of x plus h minus f of x over h. Now, f of x is given as x cubed, and f of x plus h is therefore x plus h cubed. But if we expand it, we have x cubed plus 3x squared h plus 3xh squared plus h cubed. And so we would replace these into the limits formula. We replace f of x plus h with x cubed plus 3x squared h plus 3xh squared plus h cubed minus, and f of x is x cubed. The denominator is h. We cancel out x cubed minus x cubed, and so in the numerator we have 3x squared h plus 3xh squared plus h cubed, and the denominator is h. We then factor out h only in the numerator. What we have left is 3x squared plus 3xh plus h squared and over h. And then the h factors canceled out, top and bottom. What we have now is 3x squared plus 3xh plus h squared. This is the reason why we keep writing the limit notation here, because this will tell us what to do next. We need to evaluate this limit, but 3x squared does not depend on h, so it stays. 3 times x times h, but at h equal to 0, the term goes to 0, because 3 times x times 0 is 0, and 0 squared is 0. And so the answer is 3x squared. This shows that the derivative of x cubed is 3x squared.